Alright, so it's been a little while since I've done an Advent of Code, but I really want to get the Advent of Code finished before the new Advent of Code, which comes out in December. And we have 10 stars left, a lot of which are half-finished day. Five days I have half-finished stars. There's only 3 days which I don't have any stars for. And the day we're doing today, day 19, I have 1 star for, but we're going to ignore that. And I'm actually filming this one after I completed 18. Not 18, 17 then. Yeah, after I completed 17. And I have a really cool solution for that, so maybe keep an eye out for that. It's quite unique from what everyone else did. But day 19 today. So this is the one where we have a couple of machine parts. You discover that they have a heap and there's a system. Okay, each part is separated in 4 categories, X, M, A, S. Each part goes through a series of workflows that will ultimately accept or reject the rule. Each workflow's name contains a list of accepted rules. One rule specifies a condition and where to send a part. Okay, each rule specifies a condition and where to send the part. If the condition is true, the first rule that matches the part being considered is applied immediately. The first rule that matches the part being considered is applied immediately. What does this mean? The first part that matches the part being considered is applied immediately. And the part moves on the destination described by the rule. Okay, I get what you mean. The last rule in the workflow has no condition, always applies if reached. Consider the following workflow EX, some conditions. This workflow is named EX and contains 4 rules. If the workflow EX were considering a specific part, it would perform a series of actions. Oh, if X, so from our code, X bigger than 10, :1, if the part X is more than 10, send the part to the workflow named 1. Oh, I see. Okay. So I think there's a couple of ways of doing this. That we can do a graph. Right, we can do a hash map with like graph. No, this is stupid. No need for graphs here, I think. We could. Never mind. Let's just work. Let's just cook. M smaller than 20. Send it to 2. Otherwise, rule A. Otherwise, because no other rule matches the part is immediately accepted. Okay. So A and R are like, instantly, if a part is sent to another workflow, it immediately switches to the start of that workflow instead, and never returns. If a part is accepted, sent to A, or rejected, the part immediately stops any further processing. The system works, but it's not keeping up with the torrent of weird metal shapes. They also ask you if you can help sort a few parts and give you a list of workflows. And some parts rating. Okay, so we have this. Our rules and our parts. Whoops. The workflows are listed first, then a blank line, then the ratings. So this here, and you see I've already finished part 1, but we'll start again because honestly I can't remember what even happened there. We have this. It goes in through the top. Does it go one by one, like as a list? So in QQZ. Why this one? This one goes to PX. This one goes to QQZ. Wait, why? That will oil like 7. Each workflow's name and contains a list of rules. Each one specifies a condition. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination. Okay. You know what? I don't quite understand why it goes into in. Is there always one called in? Did I miss something? No. No. Is it just the first one that will be applied? Doesn't look right. There's something weird. The workflows are listed first, followed by a blank line and the rating of each part. All parts. Oh yes, I'm stupid. Literally, it says here. Anyways, so weird brain fart. Okay, goes in QQZ, QS, LNX, LNS accepted, reject, accept. Okay, so first of all, we gotta split these up, and what I'm thinking is I make each one of these like an entry, and then I make a conditions array. We go through the conditions array, and that's a struct of some sort, describing where we have to go. Yeah, describing where we have to go. Doesn't look too bad. Doesn't look too bad. Well, clearly I got 1 star, but we won't spoil ourselves because I really don't remember what part 2 is. Okay. Let's start programming. So I've deleted what I had for day 19. Oh, here's the actual input. Interesting. Another annoying thing I have to do today is tmux is being really annoying on Zig projects. It's a strange error that I might try and fix later. But for now, we're just using our beautiful tiling windows. Makes work. First of all, let's go into main here. Day 19. Let's try and install day 19 with day 19 input here and here. And we need a pub. Was it solve that it wants? Yes. Let's just copy from here. Okay. And let's import standard library. There we are. Okay. So we have to split on that specific line. Or really we have to just process these. So first of all, let's think of our data structures. So we're gonna have maybe is it a rule? What are they called? I'm gonna say workflow. Workflow, which is a struct that contains an array. Yeah, it's just a struct with an array, but then at that point, like, do you really need it? Can I make just array? No. Yeah, I think I can do that. Now we go rule, which takes in condition and something else. And let's go const attributes. Attributes equals an enum that contains a singular uweight. It's going to be x, which is equal to x a and s. Cool. So our rule then is going to be it's going to contain an attribute. And it's going to be a value, which is going to be, it doesn't have to be usize, but it could be usize. I feel like I'm just writing terrible code and it's not really enjoying it right now. Oh, there it is, the auto formatting. Okay, and then the value, and then there's a couple of things it can do actually. It can be rejected or accepted, or it could go to another rule. And another thing about these rules is that they can be a specific thing. And right now, I wish I had Rust enums because they would demonstrate this really well. But I do not. So we have attributes, value. I mean, I really want to do a union on to describe the other rules, because then we're just gonna have kind of a weird struct. But you know, we're here to learn, so maybe Zig union structs. Let's see what this has here. Unions. We have tagged unions. Okay. This might be very much what we want, actually. A tagged union. Unions can be declared with an enum tag type. This turns a union into a taggable union, which makes it eligible to use with switch expressions. Cool. Okay. So for example, they have a complex type, which is okay, not okay. It unions on that specific enum, whether it's okay, not okay, void. So the value. Wait, how's this work? N.meta.tag or complex tag, tag. What's going on here? So the complex type c.ok, showing expect as the complex type tag. Sorry, I had to just make a cut there. Where are we? So we're tokenizing the rule. We are. Oh, we're up here. Yeah. Colon index. We're just gonna look for that little one, and then that should give us either R, A, or another rule's name. Should also give me an like an attribute. Yeah. So let's go. Oh, actually, there's a couple of things here. Because it could be if rule at 0. Actually, let's make it more robust. If rule.length is equal to 1 and rule at 0 equals I don't really like nesting. Oh no, let's not nest, you know. Oh my god, I'm so indecisive today. I actually can't do anything. A else if actually just else it's going to be reject otherwise. This is going to output a rule, and this rule is going to be a return. Oh, how do we return tagged unions again? Tagged union. Here. We do complex type the dot. Okay. Cool. We do rule at is it terminal? No, just dot terminal. Dot terminal equals the terminal except. Oh, just realized we can do this without that loop then. Rule 0 is equal to A. And it's an equals, it's slightly different there. Okay, cool. So we have our terminal there. Otherwise, we should have a colon index. We should then have a little attribute on the 0th. So the attribute equals to rule at 0. Oh, and we need one more thing actually. Need another enum const condition equals enum Oh, this doesn't really have any. It's only bigger than or smaller than, so we can just use a boolean here on our terminal expression and non-terminal expressions, and it's going to be, I'm going to say less underscore than and call it a boolean, and just going to be, you know, we just do less than or otherwise, because there's only two. We don't really need, there's no other edge cases. Otherwise, I would make an enum for it. Here we are, const, and then const condition equals rule 1, and then we're going to do, oh, actually, const the expression, which is going to be rule between 0 dot dot up until the colon index, and this is going to be the rest, which is going to be the destination, I guess, rule colon x. I think it has to be +1 here. Dot dot. And it's going to be expression. It can be either one, to be fair. It doesn't really matter. But expression, and let's just print. Let's make sure we have everything right. Oh no, I trust myself here. I trust it. Okay. So first thing we check is if the condition or the destination dot length is equal to 1, we're going to return a terminal expression that is going to have an except, wait, terminal expression, yes, except if the destination at 0 is equal to a, it's going to have a dot, let's do the attributes first actually, just do that at the end. Dot attribute is going to be, what's the thing from Zig, standard dot meta dot enum, is it field enum, returns an enum with a variant name dot reach field t into enum string to enum, Zig char to enum. Is there, actually I'm going to make another function for it. It's going to be char to attribute. It's going to be a char, which is going to be a singular u8. It's going to return an attribute, and we'll do a switch on C, and x returns attributes dot x, a s underscore else even, unreachable. It's not actually unreachable, but it's like a panic. It's a don't call this function otherwise. Here we are. Char to attribute. There we are. The value is going to be, what's the value? The value is what we find after. Condition const value, which is the expression, 2 dot dots, I think, because the expression goes between 0 and a colon. Yeah, that's correct. We actually need to convert the value to a int sig string to int. How do I pass it into a string? Try standard FMT, yeah. And we can actually keep this error free by doing it unreachable, because it's never going to be true here. Const string value is equal to standard.fmt.parse int. I think we're using new sizes, aren't we? We're going to do string value, and what else is there? Is that the base? Is there a base? Yeah, base 10. Catch unreachable. Love these keywords. Love the stuff you can do here. Super cool. Super cool, super foot gunny. the Rust devs can't handle it. They can't handle a little cheeky. I know they can. I'm just messing around with their funny macros and stuff. Anyways, to be fair, this would be a really nice problem to do in Rust. Value, whether it's less than, it's whether the condition is not continue. Condition is equal to less than and then comma. Then we finish that. Let's do. I think Zig formatting doesn't love me doing this. Workflow.length. Oh yeah, it just moves it onto the same line, which is honestly kind of grim. What if I do this? Yeah, it doesn't like it. I think Go kind of lets you do it if you put the new lines in yourself. But I guess Zig gets stricter, which is fine because it's a rule, like it's consistent. Destination length is equal to 1. Otherwise, we are going to return non-terminal with the attribute char to attribute. The value equals the value. The dot less than is equal to condition is equal to less than, and the dot the next rule is going to be the destination. Pretty cool. We're gonna print. We're just gonna do print any of build rule taking in rule. Let's just. Oh, what's going on here? Let's see what happens. So it doesn't compile. Expected type something rule, but found terminal expression. Oh yes, okay. Yeah, I have to wrap this in the union. Yeah. Like so. Like found const u8 instead of u8 array. That's fine. That, to be fair, does not have to change at all. There's a switch ignored. To discard all values assigned on the score. Isn't that what the else is for? Prong only allowing switching on non-exhaustive cases. Consider using else. Oh, I need to return the value of the switch. Yeah, that's right. Too much, doing too much for Rust. Well, it reaches the unreachable, so clearly I'm a bit wrong. But it's let's also just do print s of. I feel like I'm enjoying this day, not because it's hard, because I'm taking a longer route than I think I normally would. One of the rules is just RFG. Is that so? Ah, yeah, the end one. Okay. How could we represent this? Yeah, that's what happened on the very, very last rule, isn't it? It's almost like a different type of rule. It's almost a different type of rule. But it's kind of like my terminals. Like it's almost like a terminal, but not really. let's make another one. It's not a terminal, it's a jump, like a call, like a non-terminal jump. That sucks, that name sucks. Const non-terminal instant, which is a struct that just has next rule as a constituent. And then we have to also do non-terminal underscore instance, and down here non-terminal instance. Here we are. Okay, non-terminal instance, and that is going to happen when the colon index is not undefined. I could make it return an error. How do I do that? I'm getting way too fancy, but I'm actually like having so much fun right now. Error. I want to return an error. How do I return an error, boys? Returning an error in Zig. How do I make an error? The error syntax, error something, yeah. Or actually, no, I can do an optional. Zig return optional. Optionals, yep. Oh, this is actually kind of what I want here. I wonder if I can just do this, and I can do colon index dot question mark if colon index is equal to null. Then it actually tells us one thing. That means that there's no there's no colon, so that means it is a dot non-terminal instance where the next rule is just rule. Huh. It's quite a nice way of doing it, I think. Union field terminal ordered differently. So we have non-terminal, terminal expression, terminal, non-terminal instant. Oh, that matters. I did not know that mattered. Sure. I'm curious, how do I return an optional? How do I should I return error versus optional? How do I even return an option? Oh, is it just null? I'll do it. Else null. Yes. Yeah. Optional. Okay, colon index equals colon index optional dot question mark for sure. We can, that's the unwrap equivalent, I suppose. Cool. That's all working very nice. Our type system is just impeccable. Impeccable type system. We should actually just check these a little bit though. And it's so annoying because I don't have tmux, so I just don't know how to resize this stuff. Something really odd happens when I use tmux right now with some latest update of the Zig LSP. Okay, anyways, we have a rule here that is a non-terminal. Non-terminal terms points to attribute A. The value is 2006, less than is true. The next rule is then that. You know, I think we have a winner. I think this is all working. Which is really, really nice. And we're going to have const workflow, which is going to be an array of rule. Actually, let's just do array of rule. Yeah. Array of rule, yeah. And we can actually, we're gonna have to malloc here because we don't know it at runtime. We don't know how many there are at runtime. Fair enough. Sander.mem.allocator. We're gonna need an allocator for the rule tokenizer, and it's gonna have a var rules, which is gonna be. Is this now gonna be a thing that I have to try, because it's gonna be try allocator.alloc. Yeah, I'm gonna allocate a space for rule. And it's going to be, we do know how much it is. Kind of. It's like I'm going to try and count the number of commas. There's a, basically if you have one comma, you're going to have 2 rules. If you have 2 commas, you're going to have 3 rules. So, standard.mem.count, yeah. Const rule number equals stand.mem plus 1. The stand.count returns usize plus 1. We're all good. We're going to allocate the rule number, and we're going to go rules at index usize is 0. Index is equal to build rule with rule and then index plus or equal 1. We're going to return rule underscore number dot, no, not rule number, rules, that's what I called it, yeah. We can actually, yeah, we should actually wrap this in like a slightly nicer struct, workflow, which is equal to a struct that has a name, which is a constituent, and then the rules, which is an array of rule. Oh god, 33. You're going to just be a workflow, returning a workflow. Workflow dot name rule, let's go on name. Rules is equal to rules. Do you compile? Do you agree with me? No. Oh, because I need an allocator, so standard dot heap dot just page allocator. No need to be too fancy there. And let's see, Sheen is ignored. Try. Wait, what? Oh, the value is very much ignored. Is that all good now? Yep, that's all good. It all compiles. And we have a set of workflows, basically. What I'm actually going to do is going to be workflow count, which is going to be for input line, it's going to return 0 dot dot. If line dot length is equal to 0, we're going to break with I else unreachable, and use local const workflows equals allocator dot alloc. going to try the same. And we want workflow to be workflow count. I dot, we're going to be workflows at I equals, oh, just oh, and I need to, what am I doing? Do you run? You actually do. I just want to print, make sure I'm correct here. It's going to be a long video, but 21, am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah. Did I say 21? I meant 11. Okay, cool. Cool. We have all that. Now we need this. Now this here contains, yeah, all of these. And we can just have, what are they, parts? Yeah. Parts is a struct that's gonna have X, usize, MAS. Parts count equals input.length, take away the workflow counts. Let's just print, make sure no off by one errors here. Part count is 6, 1, 2, 3, 5. Actually need to take away one more for that new line, I think. We take away that and we're good. Workflows, parts, let's allocate them in the same place. Parts count. Let's actually do an index here. Index plus or equal 1. And we need to do one for the new line and for input at index this line prints just underscore for now. 1, 2, 3, 4, 5. Yes, all good. Yeah, let me just write function called function build part, which is gonna, it's not gonna take an allocator, no need. But there is gonna be a part, which is gonna be constant u8. It's gonna return part. Trimmed part, which is equal to part 1 dash dash length -1. And now we're going to use the tokenizer, the comma tokenizer standard.mem.tokenize sequence u8 trimmed part on the comma. Is it always in order? Am I guaranteed that? Because that would actually make things slightly easier. XMAS. Yeah, so in order, always in order. So I can just do const a is equal to comma underscore tokenizer dot next dot question mark XMAS. I don't even know what this returns, to be fair. What does this return? XMAS s, do void for a sec, and just and let's just call build part. Okay, what do you do? Oh, it needs to be a var. X underscore string underscore string underscore string underscore string a equals x underscore string between 2 dot dot, and this is going to be standard.fmt dot pass int this into a usize base 10 cache unreachable xmas mas. Okay. Lovely stuff. Return part x equal to x dot m is equal to m dot a is equal to a dot s equal to s. Cool. Const parts 0 dot dot I dot not I dot dot just I equals build you compile. Nice, all good. Okay, I think we're set now. We have all our workflows, we have all our parts, and you know, I'm actually kind of happy with the state of the code. It looks clean as hell. Or at least it's very clean from the like a type perspective. So what we're doing next is well, now I don't know what we're doing. Actually, kind of I've been so preoccupied. Well, we need. I feel like we need a map. Yeah, we need a map of all the workflows. So we have an array of all the workflows. Maybe we actually don't want an array of all the workflows. We just want a map of the workflows. Yeah. So this is going to be standard dot string hash map, and that's going to take in a workflow dot init the allocator. And we can do workflows dot put const workflow is equal to this. No need for that index there. Oh no, we do because of the other stuff. Oh no, we don't. We can just go workflow count to be fair. Like so. Then we're going to put workflow.name and just workflow. Like this. So really we didn't really need to wrap it in a fancy inner struct. But hey. All good. You're not running. Why aren't you running? Is it because you need to be a var? Yep. Okay, we have all our parts there. And now we just have to run it through, right? We start with this one. Yeah, now we just execute time. We basically just continue going until well, we're done. Until we're done. So we start it in. We're going to do some comparisons. What are we doing? What are we doing? What are we doing? So we we're going to start on that in rule. We're going to go through the rules in that rule, in that workflow. We're going to check each one. We're going to say, well, do you accept? Or where do you go? We can have like a loop that modifies like the next rule. Yeah, let's do var next rule. Next, no. Oh, sorry. You know what? Let's do workflows.get, where the key is in. And what we're going to do is we're going to go for parts, part, right, for parts. We're going to go, we start in dot rules, and then for in dot rules, rule dot oh, now we need a switch actually. Yes, we need a switch. This is where the tagged unions actually like come in useful. Tagged sit tagged unions, using them in a switch. Type code. No, it's not correct. Tagged unions, yeah. Tagged unions, which can be used in a switch. Yeah. Switch rule. What did it say? Complex type tag. Rule type. So if it's a terminal, what does it want, the actual answer? Ultimately, 3 parts are accepted, adding up to XMAS. Rating for each of the accepted parts gives this. Adding all the ratings to all of them. Okay, sure. So we're going to need another list with certain capacity. We're going to need an array. So we're going to do const accepted parts, which is going to be a allocator. Let's allocate some parts, and it's going to be at most part count, but some of it is just going to be undefined. Okay, so if it's a terminal, and let's also do for accepted parts index size of 0. So if it's a terminal, need a little bit more documentation. Terminal captures the value. Terminal dot. Oh, I'm not going to get help from him. Terminal dot something. That's super annoying. Terminal dot accept, right? If terminal.accept, then we do accepted parts at the accepted parts index is equal to the part, otherwise accepted parts index plus or equal 1. Does this compile? Switch must handle all cases. Else, let's do else unreachable, just to see if it compiles. It does, and it will reach unreachable. Okay, apart from that, apart from a terminal, which can make it accepted, we can have a, let's do just the non-terminal expression, which is going to be non-terminal. I'm going to do an underscore and then type it myself because it's really annoying. Non-terminal, which is equal to non-terminal. Like so. Yeah. So in this case, we would go to another workflow. We would, yeah, it's like we would break to be up here, basically. Yeah, I think so. We can do a while true here. Make it labeled to be I mean, this is really like a case for recursion. Recursion, I don't know. Workflow loop, and after we do this, we do break the workflow loop. We break the workflow loop. Oh, wait, my brain ain't braining right now. If it's non-terminal and we accept, we just move on to another workflow. So we move on to another workflow. Is this a job for a function call? And I'm really just overcomplicating things. Yeah, I think it is. I think we can have a function that so it's going to run a singular workflow, and it's going to return the name of the next workflow or some other stuff. So it's going to return accept, reject, oh, that's the return. Yeah, it's three things. It's actually kind of annoying. It's like we need another tagged union if we want to continue this programming style, which, you know, could be fine. Oh, yeah, let's do another one. Let's encode more semantics in the type system. State enum accept, reject, next rule. We're gonna have const state union equals a union on state, and actually a state is either going to be terminal or non-terminal, and it's going to be the terminal state. It's going to be a boolean, and the non-terminal state is going to be const u8. State union, yeah. Now this is going to have to take in. What is this going to have to take in? Not the workflow hash map. We're just going to have to take a single workflow. Part. Like this. And what's going to happen is if for workflow.rules rule, and then it's this switch here. Okay, let's leave that one for now. And let's not do any of this. We're going to return state union with .terminal, and the terminal is going to be about terminal.accept. Rule type dot. So we can have a non-terminal instant. Let's do underscore non-terminal instant. Non-terminal instance. That's going to instantly return state union non-terminal. The next rule is going to be non-terminal instant dot non-terminal instant dot next rule. Next rule. I need a little arrow here. Rule type dot. We have the terminal, the non-terminal instant. We also have terminal expression. Yeah, and the other two are going to be kind of similar, actually. So it's going to be, we're taking apart and we take in various values. Let's just write. So the terminal expression underscore terminal underscore expression. Oh, sorry. Which is going to be terminal expression equals underscore terminal expression dot. Yeah. It's going to be a little bit annoying here. It's going to be, first of all, a less than. Oh, wait. Can we be fancy? Do we be? No, let's not be fancy. Let's do if terminal expression dot less than else. Okay. And now we do like a switch on terminal expression dot the attribute. And this is just going to return a boolean, so it's actually kind of good if we do something here. And this could be its own string. Oh, guys, I'm cooking. I'm cooking really hard right now. Let's do an expression type, which is going to be a struct with just these things here. And this is going to have expression like so, like this. Oh, boom, boom, boom. And every time we have a non-terminal or a terminal expression, we're going to need to have an dot expression equals expression here. Expression or dot expression equals expression like so. That should be all good. Function is expression accepted, which is going to take in an expression and it's also going to take in a part. And it's going to be simple Boolean. Yeah. Now, I do actually really want to do something kind of funny. So if you have a 5, and it's like, okay, you're going to test like 2 less than 5, but then the other one is going to be like 2 bigger than 5 or something. I want to condense this down by maybe using negative numbers. So if you're testing on a 5 and it's smaller than, you could just test on smaller than on bigger than, and then the negative of both. Ooh, yeah, don't you just... Yeah. Yes, you do the negative of both. And then you can skip that part. So what we're gonna do is we're gonna do... Oh, but then we would have to do the... Oh, never mind. If expression dot... Wait, why no autocomplete? Oh, no autocomplete because of that. If expression dot... Let's just write a lot of code for now. Switch on expression dot attributes dot x x return whether path dot x is less than a is less than the expression dot value. A S M A S, and then this is just the same thing, but with this going this way. Okay. And now down here we have a terminal expression, and because it's a terminal, oh god, what am I doing? Yeah, because const terminal underscore expression, which is a terminal expression equals underscore terminal expression dot sorry return state union dot terminal, and it's going to be I'm actually just confusing myself so much here. If there's another outcome. There's another outcome if the rule isn't, if it's not accepted. Oh no, because it just goes non-terminal. Non-terminal is the next rule. Or we just continue on the for loop. Yeah, we don't. We just continue the for loop. Yeah. Okay, that's right. If is expression accepted, the terminal expression dot expression and the part. So if it passes that, then we got to return a state union dot terminal whether or not the terminal expression dot accepts. Otherwise, we just do nothing and continue because the expression is not accepted. One last rule type, which is the we've done terminal expression, non-terminal instance, just straight up non-terminal. non-terminal here, non-terminal here. Expression next row, and then very, very similar code to this. If non-terminal expression with the parts, if it is accepted, then it returns non-terminal come on, non-terminal dot the next rule. Otherwise, we simply continue, and that's all great. I think until, yeah, so we run it once and we go next underscore rule, while next underscore rule is not equal to null, we go run workflow, const workflow results equals run workflow parts, and sorry, I've got like dust in my throat or something. It's really itchy. Not workspace, workflow. Cool. We're going to run the workflow result. We're going to do a switch on the workflow result, like we did for this one up here. On state union, it's going to be terminal, non-terminal. If it's terminal, if terminal, then actually accept. If accept, then we're just gonna go. Oh, whoops! Sorry, doing that in the wrong place. State.terminal accept. Then we're gonna go accepted parts. Accepted parts index equals part. Accepted parts index equals 1. I think I can delete this. Otherwise, we go state.non-terminal. Next rule. We're just going to say next workflow equals workflows.get the next rule, not question mark. And actually, to be fair, this here is just true, isn't it? It doesn't really matter. It only does it over here. We break the running loop. Workflow loop. Implicitly returns. Where is this function with non-void returns stuff? Yeah, what's wrong? Unreachable? Okay, and oh, did this just work? Print parts 1 accepted parts index. Oh, it accepted 5. Well, that's not good. It accepted all of them. That means they all went in here. terminal, state union, terminal expression, accept, next row. Now it's where it actually gets difficult. So I've done all this fancy stuff with the type system to hope to avoid this type of, well, to avoid weird errors. And now I'm getting weird errors. That's great. Good place to start is to do next rule. This is string. So it starts with a Q, QZ, QZ, L, and X. Not to mention it just. Oh wait. I'm not resetting. Yeah. We're gonna break the workflow loop, and we're gonna do this. Okay, cool. I just didn't reset at the very end. It accepts 3. Part 1, use size. I think I just have to add all of them together. That's not what I wanted. For 0. Actually, we can do for accepted parts between 0 dot and accepted parts index. Does it know what parts is? Yeah, it does. Part dot x plus part dot m plus part dot a plus part dot s. Part 1 is 19114. Oh, guys, I've loved this one. Doing complicated stuff with type system, it's just so cool. Like it's so much easier. It's so much nicer. Maybe a skill issue by having to do this, but okay. Are we correct? 420739. We are correct. Let's just pretend I inputted that. Whew, very cool. I really enjoyed that. Next part. Even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all these workflows, maybe you can figure out in advance which combination of ratings will be accepted or rejected. Each of the 4 ratings, XMAS, can have an integer value ranging from minimum of 1 to a max. Oh no, not this. Oh, it's a ranges problem. It's ranges. Oh, I hate it, bro. I don't like it because there's a very easy brute force thing here. Right, you can absolutely just brute force this. Or I wonder if there's maybe a binary search solution that doesn't require such complex, like, range analysis almost. Okay. Each of the 4 ratings can have an integer value ranging from 1 to 4000. Of all possible distinct combinations of rating, your job is to figure out which ones will be accepted. So is this... wow. Is this basically saying start with XMAS at... So we can do a loop of 4000, 4000, 4000, 4000. But, that sucks. Trying to think, because it's also not very clear what the binary search solution is here. How do you do this? You and even there's so many different combinations, right? Like if you start with what do you do? You could start with X. like being a certain value. Right, you binary search the value, right, between 1 and 4,000. You say, well, it gets accepted at anything below 3,000, let's say. Anything below 3,000 exactly. But then you move on to M, which could change that, right? M could now also kind of mess with your plans. So, oh, this is weird. This is a linear programming question, like a really complex linear programming question. I'm actually not sure. I'm not sure what's best here. Let's keep thinking. Doing binary search works for single values for x, m, a, and s, right? If all the others stay constant. But that's no good to us because we need to find entire combinations of values. And there's not like a perfect number where it will all kind of work. And brute force is way too... No, you can't brute force this. The number's too big. Yeah, it's just too big a number. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's millions, billions, trillions. Like, I would literally be here for weeks brute forcing this, I think. Leave 4,000 was... Yeah. 4,000 times 4,000 times 4,000 times 4,000. Yeah, it's just... It's not happening, basically. Even in this faster language, it's not happening. I'm trying to think of ways in which you can lead the very first result from X into the rest. So if M, A, and S are all 1, and X is like 3,000. If you then move on to M, and you start adjusting M, no, that's no good. That's no good. Such a shame. I enjoyed part 1 so much, and I feel like I'm gonna actually be deterred by this other part now. I'm gonna have a look around, see what other people have done, see what you can come up, because I actually have no idea right now. So I kind of did the entirety of part 2 whilst I was off screen. I've just finished it, and it was hard, and I didn't figure it out myself. I actually used this video from this guy, Hyperneutrino. Really like incredibly helpful. His code is super concise, and it really just broke down the problem like so quickly for me instantly. Like I'm not gonna try and explain the way he did it much better than anything I can do. But you're going through all these rules, and each time you hit a statement or an expression, you just tighten up your range a little bit, and that slightly tighter range that goes into that expression, you recursively go deep, right? And then you add that total up. So these non-terminals here, this is inside of a for loop inside a workflow, and we're going on by the rule. If we get the range, this is kind of boilerplate up here, don't worry too much. We get the truth and false range. So the thing, remember, it's a less than or a bigger than statement. So we just tighten it up depending on that statement. And then we grab that tighter range for the true value, right? out and we do a plus or equal on whatever the count range is for that new workflow is, because we don't really know what it's going to return. It could actually just return 0, but we just offload it. We get it then. The next thing is we take all the false values that didn't go and sink deep into that rule, right? And we just tighten the entirety of the range. So range is declared right at the top here, and we mutate that. One of the things I was missing when I was thinking about the problem was that you never come back, and I knew that. I was like, you'll never come back, yeah, but I did not think that I could just mutate the range like this. Right? I didn't think, surely I have to account for some holes in the range or some. I was making things up in my head, honestly. But you can, because you just never come back, and you can just disregard things completely, basically. A lot of stuff. And these extra if statements, by the way, are just so you don't end up doing useless operations, right? The is empty function is really simple. It's just if the low of a range is more than or equal to the high, that means that the range is kind of just empty. Saves on things. And the meat, I suppose, of the operation comes in this terminal and this terminal expression. So the terminal, remember, this one just says accept or not accept. And all you have to do is you say, if you're accepting, then add up to the total the sum of the ranges. The sum of the range is just x, m, a, s, all times together. Oh, that's wrong. It's not a sum. I just realized it's a product. Let's just commit that. Fix spelling. Fix method name. Okay, and then on this one, and if it's not accepting, then, well, you're not adding anything, you're just rejecting whatever happened when you got here in the first place. And then something very similar happens on this terminal expression. Remember, a terminal expression is a statement. That's it. It's a statement that then leads either to an accept or a reject. So either this accept or reject either accepts or rejects. We grab the truth and false range, and if we are accepting, then we add it up. If we're rejecting, we don't do anything. We're just not doing anything if we reject, because if we reject, well, that's it. It doesn't add up to the total. We're not taking away, we're not doing anything. And then we're just, again, tightening the range on the false. So the false is what continues down the same workflow without going a level deeper, and just continues tightening and tightening and tightening a little bit. And it's so clever. Like this, I love this problem now. Now that after I watched the video, I thought, oh my god, this is so cool. Like the way it works is really sick. Because what I thought we would have to do, I had two solutions in mind before I kind of gave up. One was some sort of geometric solution, like a 4D cube, where you do some weird like binary search on the sizes and you try and find the correct dimensions, but that didn't work because you're not guaranteed. There's no like convergence. It's not an optimization problem, because you can have a range between 0 and 100, and you could have a sub-range like on certain rules between 0 and 100 is true, and on some other rules between 50 and 60 is false, like specifically. So you can't just you can't linear program your way out of that. So that was my first one I kind of threw out. And my second, which I kind of sketched and I was playing around with until I think it works actually, because I then had a look on the subreddit, and a lot of people did this second approach, which is where you build a tree. And from that tree, you never have to run ranges through, I believe. I think you can build the tree in such a way that you can look on the accept nodes, backtrack, and figure out the ranges from there. That would also be very clever. But then this solution from Hyperneutrino, it's really good. Like, really check out this video. It's amazing. he does such a good job, and I mean, this is you cannot get better than like the simple code that he showed. With this like little tightening range solution, feeding an initial range through. So the very initial range I feed through is just completely open between 1 and 4,000. That's what the problem wants, and that's it. We just count ranges. Super simple. What else is there to explain? I mean, it's a lot. It's a hard one. I'll admit it took me a while, and I didn't know. I never really dealt with ranges, to be fair. I think there's another. Maybe it is just this one. Problem to do with ranges that just completely stunts me. Like, I should get better at stuff like this, and now I have. I feel like I'm okay now after having done this. Yeah. The only last thing is this non-terminal instant, which is, if you remember, the one that just says go to this other rule, and it's pretty simple. Like, we just basically offload everything to the next rule that it wants. Yeah, I'm super happy with this day. Even though I had to look up part 2, and I didn't do it myself, I'm really happy I actually, did it. So I still understand the problem very well. And actually, I'll give myself props, because the way that the Hyperneutrino coded this solution to make it simple and like the less amount of code possible, I suppose, to like explain, he separated the very last part of the rule. This one here, he said the except dv, because then you are taking the two things that I put into the type system, and you're kind of not putting them in the type system so you can handle them separately, which is really fine. But there's something clever about my solution, I think, where you could, in theory, move the A into the middle of one of these, and it would still work. I know it's the Heaven of Code. We don't care about that stuff, but I think there's something there. It's quite neat, and I took today as kind of a long day. Like, look how much typing there is. Like, I think this is maybe one of the longest solutions. There's so many structs. That's all structs, right? And a lot of that is because of this the tagged unions, especially this one with the rule. You know what? I love this. I think this is really cool, and I knew Zig did something like this. I didn't know that they would just like this nice. They're basically the same as. I'm gonna offend a lot of people here, but they're very similar to Rust, right? And it's nice. It's really sick. You can just do exactly what you would do in Rust with enums and create a union. Yeah, just really enjoyed this day. Got to play around with the language. One thing I'll say, a little bit of criticism, is the language server. There's this kind of annoying thing where it doesn't know what this is, for example. Like, I don't get any autocomplete here, so I have to do this thing. You probably noticed this line, non-terminal instant, which is of non-terminal instant that points to underscore or is equal to. Only because then I can get autocomplete. And I think autocomplete is the power behind tagged unions. It's almost like tagged unions are really cool in a code structure way, but I think their real power is enhanced when the LSP knows to narrow things down and give you the correct properties at the correct time. Obviously, the compiler will do that for me. It won't let me compile if I do something silly, but it would be nice to have that time feedback. So, if anyone from ZLS is listening, I would really, really love to have this on. Obviously, thank you for the work that you do completely for free, by the way. Yeah. Okay, guys, I'm going to wrap this one up. Thank you so much for watching. I'll catch you in the next one.